Today we are going to graph some other trigonometric functions such as tangent, cotangent, cosecant, and secant. First, we are going to write these in terms of sine and cosine. Tangent is sine theta over cosine theta. Cotangent is the reciprocal of tangent, so it is cosine theta over sine theta. Cosecant is the reciprocal of sine, so that's 1 over sine theta. And secant is reciprocal of cosine, so that is 1 over cosine theta. So we're going to graph y equals tangent theta. Tangent theta is sine theta over cosine theta. Because cosine theta is in a denominator, the domain is that cosine theta cannot equal 0. So in order to make sure we fit within our domain, we are going to graph a cosine wave. So basic cosine wave, y equals cosine theta. That'll begin at the vertex, which will be 1. Okay, the standard amplitude here is 1, and it will repeat every 2 pi units. So it's going to go down and back up at 2 pi. So there's one cycle. There's another half cycle, and then we can go back to the left. Every time this graph touches its own axis, that is where it equals 0. So our graph is going to have asymptotes every time y equals cosine theta equals 0. Those x values cannot exist. Okay, so we have drawn that sine wave only so we could find these asymptotes. So all those dotted parts aren't really a part of the graph, they're just helping us build the graph. So now the graph is going to be a series of different parts, so it'll be piecewise within each interval. Each of these is going to, within each of these intervals, it's going to cross over the sinusoidal axis of that cosine wave. And here's what it will look like. It looks a lot like the graph of a cube function, repeating over and over in each interval. Okay, so when I have solid red, that is the graph of this function. Okay, now the period. Every time it repeats. So let's say we start here and go that far. There's one cycle. So the horizontal distance of that one cycle is a period. Each interval here is 1/2 pi. So between the asymptotes is pi. The period is pi. Okay? So that period is the base period of a tangent graph. In a sine or cosine graph, the base period is 2 pi. So what that means is that b for a tangent or cotangent graph is pi over the period instead of 2 pi over the period. So cosine, sine and cosine is 2 pi over the period. For b, because the base period is pi, it is 1 pi over the period. So now we'll graph y equals cotangent theta, which is cosine theta over sine theta. And because sine is in the denominator, sine theta cannot equal 0. So we'll build this graph beginning with a sine wave, which starts at the on its axis. So up and down and back, and right there is one cycle. Up and down, there's another half cycle. And then to the left, down and up and back. Okay, so there's another cycle. Every time the graph touches its own axis, that's where it equals 0. And since it can't equal 0, that's where we're putting our asymptotes. Okay, so all that is going to help us build our graph. The next difference, first difference was that sine can't equal 0. The next difference is that these graph backwards compared to tangent. It still needs to touch right there on the axis midway through the interval. Okay, here is the horizontal distance of one cycle, and once again it is pi. So for tangent and cotangent, the base period is pi. Okay, so the next graph we will do is a secant graph. Y equals secant theta, which is 1 over cosine theta. So cosine theta cannot equal 0. So we'll graph a cosine graph starting at the vertex. Every time it touches its own axis, we're going to have an asymptote. Okay, so we started this, building it the same way. A difference between secant and cosecant compared to tangent and cotangent, what we had before looked more like cube functions. This is going to look more like parabolas, and they're going to be going upward and downward at each vertex of that cosine wave. So there is our graph of secant theta. Another difference is that the period is longer because this right here is not one cycle because the next interval does not repeat because it's down here. Then it begins to repeat. So a period goes that far. And that is 2 pi. So the base period of secant and cosecant is 2 pi, which means B, for our equation, is going to be 2 pi over the period again. So it's only different from that when we're doing tangent and cotangent. So sine, cosine, secant, cosecant are all 2 pi over the period. Tangent and cotangent are 1 pi over the period. So y equals cosecant theta is the same as 1 over sine theta. So sine theta cannot equal 0. So we'll start this graph on its axis. So there's a sine wave, and every time that wave touches its own axis, it equals 0. So that's where we will have an asymptote. Okay, so there's the structure of the graph. Now the graph itself looks a lot like the graph for secant theta. One of these and one of these makes one cycle. So there's the period. The period is 2 pi. So number 9, y equals tan theta plus 3. That plus 3 tells us this is going to shift up 3. Tan theta plus 3 is the same as sine theta over cosine theta plus 3. And with cosine theta in a denominator, I know cosine theta cannot equal 0. So I need to graph a cosine wave, but it needs to be shifted 3 units up. So that is going to be the sinusoidal axis of this cosine wave. So I'm starting one above the axis and graphing a cosine wave up here. And every time it intersects its axis, I have an asymptote. I think I missed my spots over here. So I'm going to have to redo this graph on this side. Okay, this is a tangent graph. So it's going to look more like what we had on page 1, numbers 5 and 6. So the graph is going to look like these two, for tangent and cotangent. So every time it intersects its axis, I have my asymptotes. Halfway through those asymptotes, I've got a spot that I'm going to have to go through. And there's my graph. Number 10, y equals cotangent 1/2 theta. That 1/2 right there is inside of that cotangent function, so it is going to be a horizontal dilation by 2. So because it's cotangent, it's cosine over sine, so cosine 1/2 theta over sine 1/2 theta, which means that sine 1/2 theta cannot equal 0. Sine wave starts right on its axis and is not shifted up or down, so it's right here on this axis. But it's got a horizontal dilation by 2, which means instead of going up and having a vertex right here, it's going to be stretched way out to here. every time it touches its axis, there will be an asymptote. So I've graphed a sine wave twice as wide as the basic sine wave. Halfway through each interval is the point that I'm going to have to go through. And this one is cotangent, so it's going to be backwards compared to tangent. And it's going to be wider because it has that horizontal dilation by 2. Okay, here inside of the function, we have a pi over 2, which means this one is going to shift left. Pi over 2. And it's the same as 1 over cosine theta plus pi over 2, which means cosine theta plus pi over 2 cannot equal 0. So I need to graph a cosine wave that is shifted pi over 2 units to the left. So here's negative pi. Pi over 2 is a half, so it's negative half a pi. So it's shifted that far left. And it's cosine, which means it starts at the top. So here is a basic cosine wave shifted pi over 2 units to the left, which actually is exactly the same as a negative sine theta graph. Okay, and as secant, this is the one with the parabolas. So I'm going to first draw my asymptotes every time it touches its axis. And now in red, I will put the graph. And there is our first parabola, and then one that goes up, always on the maximums and the minimums. And our last graph is y equals 2 theta, y equals cosecant 2 theta minus pi, which is the same as 1 over sine 2 theta minus pi. 2 theta minus pi. Okay, so this right here cannot equal 0. The transformations that take place, there are 2 of them. There's a horizontal dilation by 1/2, so it's going to get narrower than usual, and it's going to move right pi over 2 units. So we're going to shift right pi over 2. It is sine, so it starts on its axis. And it's half as wide as normal, so instead of going up to a maximum right here, I'm going to go right here and be at a maximum, and back by the time I get to pi. Every time it touches its axis, there's an asymptote. So there's going to be a lot of asymptotes on this one. So every half pi units, there is an asymptote. And for our last two, we are going to write equations. So to write an equation, just like a sine or cosine wave, we need S, A, D, and B. So we have a secant function with a period of 17 pi. So B for secant, we saw on the previous page that it's 2 pi over the period. So B is going to be 2 over 17. A phase shift of negative pi, so displacement negative pi. A vertical shift of 63, so sinusoidal axis of 63. We're not told about any vertical dilation, so the amplitude will be 1. So y equals sinusoidal axis 63 plus the amplitude 1 times secant B times theta, and then opposite of the displacement plus pi. And last, number 14, once again, S, A, D, and B. This is a tangent function, which means that B is going to be 1 pi over the period. Okay, so when I do my outer loops, I get 4 pi. Inner loop is pi times 1. So B is going to be 4. Phase shift, displacement, pi over 2. Vertical shift, negative 5, and nothing about a vertical dilation, so amplitude is 1. Y equals negative 5, sinusoidal axis, plus amplitude 1 times tangent, and then B, 4, theta, and then opposite of the displacement, minus pi over 2.